Welcome to Clever Classroom IT. My name is Phil Mellifont, and in this series of Clever Classroom IT, we'll be looking at a range of issues that are relevant to schools to do with technology and learning. We want to look at teacher professional development, identifying the hardware and software in your school, and a whole range of issues with invited guests that will challenge the way that you think about technology and learning in school and at home. We're going to take a look at classroom multimedia in secondary classrooms, and to help us with that I have Ron Van Vliet from the Catholic Education Office at Parramatta. Welcome, Ron.
Thanks, Phil. How are you?
I'm well. We're looking at Hyper Studio and some of the work that students have been doing in Hyper Studio.
That's right. Hyper Studio multimedia authoring environment, I think it's got a bit of a bad name as a, well, not a bad name, but a misplaced name as a primary application. But it really has some great applications in high school as well.
Okay.
For creating a whole range of different applications and using in different ways in the classroom.
And to give us a taste for it, I think you've got some samples here.
Sure.
Yeah.
I have a couple of little samples that have been done at different schools by different people. So I'll just open those up and we'll have a quick look. And the important thing in these samples is that the way they've been used in different ways in different schools. This first one, for example, is a stack which is created by a maths teacher. Now, for those people that might be a little bit
rusty
bad
on
memories,
the maths. I might be rusty on the
bad memories about maths. Don't worry too much about the formula that are in here. It's really the principle. And the way that the teacher has used this particular stack is they've used it to replace some of the teaching methods they've had previously, using a textbook, or using a blackboard, or using overheads. And their comments in using it have been that the kids have found it much more exciting, much more interesting, much more motivating, and he's able to then pass that information on to the kids in terms of giving them a disc and they can go back and review it themselves.
Yeah.
So a few nice little animations here. They go through some of the basic principles, a gradient, and they give a formula, and then they substitute, and they simplify. And then when you click on the animate, we get a little animation happening here. And for those who remember their mathematics, they can relate to how difficult a concept that is to describe to children using a static medium like a blackboard.
Yes.
And a computer really provides that dynamic environment.
This could be used with a large screen projector or individually in the computer lab.
Certainly.
Or even on disk for students that came home to take home and practice.
Yeah, a data projector is an excellent way to use it, but then the children go back and review it themselves on the computer screen. The second one, similar type thing, another mathematical concept with another different type of animation here where they've got the area of a circle and then they've got the area of a shape, and the shape will move over the circle, and then they're talking about the area in between these two shapes. And again, the concept when we click on more shapes here, another little animation, which leads on to the theory of limits, how as things become larger, the area becomes smaller. We won't go into the mathematics of that, as I said.
Okay.
But simply to show that it is a dynamic, active medium which they're able to use.
All right. Hyper Studio. So this is multimedia and mathematics, and I think
right.
that would challenge probably a lot of teachers thinking that multimedia mightn't necessarily fit into.
Very much. As I said, it's used a lot in primary schools, and it tends to be used a little bit also in computing studies type courses, but there's many other applications across all KLAs where it can be used. One more example, which is a computing studies example, and this was another example of a different way of using it, because this was designed by a Year 11 student, and their brief was simply to design a design of a computer, or present a project on a computer which could be used by Year 7 children who didn't know anything about a computer. And children use various different media for this. This child happened to use Hyper Studio. So he used a digital camera and took some photos of the computer itself, and as you click on various components, these little pop-up boxes appear which tell you information about those different components. Keyboard, and some other photos. If we click on the drive, then it'll open up and show us the inside of the computer itself. And we can also have a look at the back.
And this could easily be used in for design studies, or for geography or history or
That's right.
sciences.
Many uses.
Yeah.
Certainly.
We're just running out of time, and I understand that you're going to come back and show us how to quickly build or modify some of these
That's
stacks.
right. Yes, I'll show you another quick little stack and show you how you can put it together using the advanced Hyper Studio
Well,
technique.
thanks for being with us today.
Thanks very much.
Thank you. The topic is Networking a School, Part 2, and I have Jeff Buchanan from Jigsaw Technology again with us. Welcome, Jeff.
Thank you, Phil. Welcome to you.
Like last week, we had a conceptual view of networking a school, like why, and we're going to get into the nuts and bolts this week very quickly.
Exactly. There is a lot of stuff to cover here. We're going to get right into what the considerations you need to take into in designing a whole network, what are switches, routers, hubs, what a file server, what RAID solutions are, what tape backups is, And by the end of that, we'll know everything about network operating
Excellent.
systems that you were ever afraid to ask.
Okay, thanks, mate. Let's get started.
Super. The first thing about networking is the three basic building blocks: network principles, how you set the whole thing up, what are the design considerations and what the limitations of it, the actual hardware that you would
Select.
to put into the system, and the network operating system, what controls the whole thing, as you said last week, what is the brains or the heart.
Okay.
A network interface card is what sits in the actual PC. Every computer should have that. That's what connects the computer out to the network, and they're called NICs, Network Interface Card.
Okay.
Pretty tricky. They're available for all machines, Apples, notebooks, PCs, whatever. The way that the network card actually talks to a network is called what's a protocol. It comes from the 17th century when they used to set protocols for the way to communicate. You've got SPX, IPX, you've got TCP, IP, and you've got NetBEUI. Each have their own advantages. The one that the internet has standardized on is TCP IP, and that's the one that most people are leaning towards.
Great.
Each have different advantages once again. The way that you connect physically the computers together is via Ethernet. This is a method that the packets are actually communicated in. And you have Ethernet 10 base, you have Ethernet 100 base, and you have 10 and 100. These are the speeds with which you communicate down the
So
line.
is there an easy answer for schools? What should they be looking for?
10 is kind of the entry level that you should be considering. 10 or 100. 100 is super fast and it's not really necessary at this point in time.
Right.
The way they actually physically connect together is via UTP, unshielded twisted pair. We covered that last week. That goes into a switch or a hub, which is like a concentrator, and that goes out via fibre to the file server. So it's quite easy when you look at it like this, how it actually looks and how it's actually put together. We'll now cover actually switches, hubs and routers. What's the difference? A hub is a device that connects a whole lot of computers together. It has no intelligence. It's just like a large megaphone. The types of hubs you can get are 8, 12, 16, 24. That's the number of ports you have on a hub. And you can cascade hubs together. And once again, we get into speed. But basically, a hub is an unintelligent device just allowing you to connect a whole lot of devices together. The advantage is they're cheap. Lots of companies sell them, and they've been around for a long time.
Okay.
The disadvantage is, once again, you only get what you pay for. They are cheap. They cause network congestion because they don't recognise addressing. It's kind of like the Sydney road system. Out of peak hour, it's really good. In peak hour, you're in traffic.
Congested.
So that's a hub, but they are cheap, and they are a way to segment a network with a switch, and we'll get into that in a second. A switch, now this is where it's really important. A switch is the backbone of the union network. A switch will, we've got to cut that part out. A switch will segment a network into virtual networks. So a switch is an intelligent device that will recognise the IP address on the beginning of a packet.
And that's actually directing it to which workstation needs that information.
Right, it's not spanning it out to all workstations as in a hub.
So in a sense, it's like a traffic cop or something?
Exactly.
Okay.
And then in the smaller areas, you can put a hub, which has a small number of PCs that actually work back up into the switch. They actually read the IP address and they send it to a direct PC.
Okay. Now these are more expensive, aren't they?
Of course.
Yeah.
Of course, you only get what you pay for. It's a commercial world. They probably run about probably 20 to 30% more than a hub, a switch. Switches will learn where the traffic's going and they will direct it. The types of switches are the same as hubs, but most importantly, a switch is an intelligent hub. They look the same for all intents and purposes. They do the thing, one's intelligent, one's not. And you can get them all sorts of various speeds. The advantage of switches, they reduce network traffic at peak periods, and they learn where things are going, and they don't slow as much. And the disadvantage is dollars.
More expensive.
Connecting to fibre, whether you've got a hub or a switch, you need a transceiver, because when you're connecting in between buildings, you need to run fibre. A whole lot of reasons, generally the static differences and distance limitations. So you need fibre. At the end of each fibre, you need a transceiver. $1,000 each. Costs money, but you have to do it.
Right.
A router. What is a router? A router is an intelligent modem.
Okay.
Same sort of analogy as a switch, right? A modem is an unintelligent device that connects you out to the telephone line. A router has software in it that allows you to configure it with firewall, with proxy, with a whole lot of things.
Okay.
More expensive, once again. How you connect the whole thing together at the backbone of the unit is the file server. The file server is the actual hardware that connects everything together. File servers come with processors, they come with CD stackers, they come with RAM, they come with all sorts of things. The bigger the server, the more processing power you can do.
Great.
the different speeds of the processor, they're always getting faster and faster because applications are demanding more resource time. RAM is the random access memory of a server, and that's the short-term memory. Right, the types of hard drives that you connect onto a file server, SCSI ultra-wide is industry standard.
Okay, and that would be the fastest?
It is the fastest as it stands today, but there's a new one coming out, but we can never wait for that because there's always be a new one coming out.
Right.
That's just the way it is. RAID, redundant array of interchangeable disks. If you've got lots of money and you don't know what to do with it, buy a RAID controller.
Right.
And there are different types of RAID. CD-ROM sharing and caching of CDs. You can buy a CD stacker that allows you to span CDs out across your school network. Once again, this hangs on your file server, or if you've got more money, you can plug it straight into the network.
Okay.
And that will go out across the network.
So how many CDs would a stacker hold?
CD stackers generally hold 7, and then you just daisy chain 7, 7, 7, or you can populate them with 3 in one, 7 in the other, so then you get 10.
Okay.
Backing up, you should consider seriously backup devices. That's very important to back up just the data, not the applications, not the operating system.
So everyone doesn't lose their work.
Exactly.
Yeah.
The network principles, most importantly, this is how you set up your whole network to make it work. And the way you design this is the way in which it's actually going to operate. Spend a little bit of time on planning this, because this is what actually makes the whole thing run. Users are individual people. Users are assigned to a group. Groups have certain rights. Groups are then assigned to a logon. So that's the way the whole hierarchical system of a network works.
Great.
The users are logged by the groups, logged by your sign-on, give you security, give you access, controls.
So a teacher would have more access than what a student might have, for instance, and a computer coordinator might have more access than a teacher.
Generally, computer coordinators are referred to as God.
Right.
They have access to everything.
Right.
Beneath them becomes the principal, beneath them comes the leading teacher, and beneath them come the students.
Okay.
And you give different rights to different people.
Levels.
And it's all flexible. You can set up whatever you want. The network operating system, this is what actually does it. They all have the same basic characteristics. And network operating systems are all basically the same. It's just how they do it. It's tomatoes and tomatoes.
Okay.
Novell used to be rolled out to all the schools and is still doing that. And is probably the most widespread and widely known network operating system across.
Okay.
From that you can connect Windows to network, Macintosh, Unix, whatever. And it all has certain features and functionality. The network operating principles is an ideal platform for basic file and print applications, connecting to the internet and also as a web server. And setting up your own intranet email, that sort of thing. The one that competes directly with Novell, thank goodness, we've got a competition, but unfortunately it's Bill Gates' Microsoft NT. It does basically what Novell does. It's almost exactly the same, it just looks a little different, and it does things in a different way. Right. It's a little more advanced because it's a little new, but Novell are catching up. Right. And different features of each. It's a little more streamlined, it's an administration. The administration overhead to run an NT network is a little less, if you don't know either, than learning a Novell. The Mac OS have been around for a long time, and they have a really good network operating system. You can run Mac into Novell, and you can run Mac into NT. Right. They're all compatible.
The choices are the same.
Yes. And that's about it, but most importantly, it's deciding and getting a game plan together, designing the network, setting up your user profiles and policies, and really talking to people and finding out exactly what it is you want to do, and then discussing it. And technology is constantly evolving. It's not a static identity.
Thank you for sharing that with us, Jeff.
Thank you, Phil. There's a lot in there and there's a lot to do, but don't be scared. It becomes a lot easier the more you talk about it.
Great. Thank you.